No one intends to drift. It's just an outcome of a highly complex set of constraints that lead to the fact that it's really, really hard not to. And this project isn't really about getting zero drift. It's about just kind of getting an asymptote to chasing as little drift as we possibly can. And to do that, we really need to build a system that is at the same level of complexity as the problem, but that gives the user a remarkably simple interface.
There are online spraying courses and reams of material on the ideal spraying application, what not to do, how boom height affects droplet dispersion, etc. But the issue is that there's so much and it can be contradictory for the end user and the farmer. It can get overwhelming and it can sometimes get put into the too hard basket as a result.
The parameters change from region to region, from farmer to farmer, and from one spray window to the next. When we spoke to a lot of the experts and tried to pin down what makes for the best spraying conditions or what do you think is the key to tackling this problem, the answer would invariably start with, well, it depends. One thing there was a general consensus on is that any solution or attempt to tackle this issue needs to be as easy as possible to deploy and really not get in the way of the farmer, doing their job. There was also some consensus that a solution needs to not only look at drift risk but also efficacy and make the argument for best practice with both of these in mind.
So one of the things we've seen through the interview series is that you've got some people who are taking higher level rules of thumb and actually in a sophisticated way trying to navigate that complexity and doing a really good job of it. Others are just giving up.
We're talking about a process that's as complex as a pilot planning a flight and taking off and landing whilst responding to weather patterns. And yet a farmer we don't equip with the same level of instrumentation. So we kind of have to expect that drift events will happen.
When we architect a new solution, we look deeply into the industry we're working in, but we also look to other industries to see how they've solved problems that are similar or have similar components. If the product or solution is right, it is possible to transform an entire industry from policymakers through to end users in a really, really short amount of time. When you walk into LX, we've got a quote from Thomas Edison up on the wall that says, "There's a way to do it better, find it." And that's exactly what has been done here. And I can see how in the spray industry we can give exactly the same kind of tool to help just do this in a way that relieves the burden from the operator to allow them to focus on the things that are really important to their operation. So we had a bit of fun when we came up with the name for this solution, Maverick. We liked the idea of, in the same way that Tony Stark has Jarvis, giving our operators in the spray rigs an assistant that really speaks to the level of sophistication. I mean, Maverick is the top pilot in Top Gun school and is a little bit cheeky. He likes to push the boundaries of what's possible. We felt that this could resonate with the target market.
We followed a similar process to that which we use in our design house, where a client comes to us with a problem or an opportunity. As a part of this process, we interviewed and spoke to a wide range of different people in the industry, from researchers and scientists that have studied spray drift for the past few decades, to members of the governing bodies, agronomists and a lot of end users and growers. We also learned from farmers and agronomists that the cost and time spent to implement new systems was likely to be a barrier to adoption if we got those wrong. So we spent time thinking about this to create different entry levels and how, as these levels increase, you have more opportunities to spray because the windows become wider, less restrictive. The fact that they can build the system over time into exactly what they need and it doesn't get any harder to use will also be an attractive prospect.
So for Maverick to be born global, we wanted to ensure that it could easily adapt its operation to optimize within local laws and regulations.
With these we can optimize for high-level rules like don't spray within 4 hours of rain, and also look at volatilization risk, as well as optimize for spray windows not just on drift risk, but on translocation efficiency and plant stress. After all, the goal is not just to land the chemical.
Over time, we believe these data sets will provide valuable insights when we evaluate the overall efficacy, as Maverick will have information we've never had access to before.
To ensure the system can be used in locations where there's little or no connectivity services, we've integrated the system with a private network solution that allows an operator to just pop up a base station on their property to give them the connectivity they need to enable the system to work.
We've taken an agnostic approach that makes it really easy to instrument any piece of equipment from any manufacturer of any age or any spray controller. So an entire retrofit is possible in a number of hours. Whilst Maverick has the ability to interface directly with existing systems, our focus has been to ensure that there isn't any reliance on existing systems.
How many farmers perfectly record the exact conditions leading up 14 days before a spray event? Or have a system that tells them the urgency of getting on the ground now as opposed to waiting a few days? This is the first generation of our spray advisory system. This is Maverick.